Hey everyone, I'm David Room, and tonight we're going to be working on some game dev with Python, working on my retro space combat game. Probably just kind of a chill time tonight, working on some different debug visualizations and things. I'll talk more about what I'm doing as we get into it, but just thought I'd go live. I haven't been going live too much lately because I've been super busy, but I need to get back into the habit of it, and thought I would just do something chill like this. I'm just gonna uh, retweet on Twitter that I'm live now, um, so anybody from Twitter can hang out if they want to. And I just want to say before I get started that my hope is that if you're uh, watching this stream, if you stumbled across it at some point, that um, as I'm working, and if you're inspired to watch, that you're also inspired to work alongside me on some creative project that's important to you. And if you're staying up with me, it's not super late here, but it's getting on in the evening. If you're staying up with me working on something, a creative project that's important to you, I'd love to hear about it, and I'd love to hear about your creative pursuits in the chat. So with that, let's get started here. So I'll just show a little bit of what I'm working on here. For anybody who hasn't been watching these streams, I have a science fiction project that has a number of different sort of outlets. I do some high detail 3D art. I do some 3D printing of ship models, and I'm making this game. I've also written a couple books that are set in my world that these other things are set in. And so this is a retro space combat game, and I will just show an example of what it looks like. So something I've been working a lot on recently is some of the visualizations. They're sort of a map mode or external camera mode in the game that lets you kind of interactively view the fight. And I've been working a lot recently on just some of the stuff like the ship behavior trees, what you might call AI. It's not really AI as that term is used anymore, but some of the behavior trees, some of this visualization stuff. I need to kind of overhaul the physics, some of the physics stuff soon, and I've got some resources to do that. But before I do that, I just want to make sure we have all of the tools that we need to be able to visualize the sort of complex things that are going on in this game. I don't want to build something where I'm just throwing stuff at the wall and kind of seeing what happens. I want to be able to understand it. So yeah, to that end, I've been working on a lot of visualizations. Let's just take a look at a scenario here. And something that I started doing is I started making these scenarios that kind of can just play out automatically without interaction from me. And that way we can easily test things, visualize things. We can set things up in a way that we get cool visuals so we can share on social media. You can debug all kinds of different things. So let's take a look where we're at. So this is a test where a bunch of small fighters are attacking this frigate, and we're in an external mode here where the camera is in the local coordinate system of the frigate. I'll actually make the screen here bigger in a second. And we're kind of following it as it's taking. I was updating some logic with the turrets and behaviors of ships and different things. So this is a visualization that's testing a lot of different things at the same time. And actually, let me just change the resolution here. And I'll run it again, and you can see this is fully interactive. I'm moving the camera around now. I added some nice shortcut keys too for like auto zoom in and out, and I think, yeah, we can recenter like this, so we can view a lot of things. We can go to sort of a global coordinate system for the camera, so we're not kind of locked in relative to the ship. Oh, it's something happened here where it oh yeah, the behavior got turned off somehow. Yeah, there's some bugs here with behavior trees too that we got to work out. Like something happened here while I was interacting with this, where the behavior on that ship got disabled. Oh, maybe did I just hit R? Let's see here. Let's see here. There's a shortcut key for toggling. Oh, maybe, let's see here. Oh, there it goes. Yeah, I just had to go back to, oh, that's interesting. Something is going on here where, oh, that's funny. Something is going on here where the behavior tree is getting disabled in the map mode. I'm not sure why that is. So yeah, different little things to debug. Anyway, we're not going to be adding any crazy new features tonight, just debugging, cleaning stuff, refactoring. So I thought I'd call this a chill stream. And something that might be sort of visually interesting is I do want to add some things to add debug indicators for velocity. So that will be sort of an interesting visualization, and then maybe just kind of refactor some things into different modules. I've kind of realized as I've been revisiting this gameplay code that it's kind of a mess, and I wanna clean things up. So let's just get started, and I'm gonna get some music started. We're gonna listen to some White Bat audio as usual. Actually, just gets restarted here. Make sure this is all the way up. Oh shucks, screwed that up. Okay. Oops. There we go. All right. All right. Okay. Nice. So Slim Kaka says, "Hey man, how's your night going?" My night is going great. How about you? Gotten everything I wanted to get done for the day for the most part, and everybody else is in bed, so now I get to work on my project. So let's so what I'm picturing for this debug visualization is just some arrows that show on the ship, and on the different ships, and I want to have this be a pretty general feature, so I'm gonna start structuring it right away. I don't want to make it too hacky. So let me see if I have some debug this stuff already. I think I have a module called debug. And what's in here? Yeah, this is like debug UI widgets, debug spheres. Yeah, see, like this is the kind of stuff that I want to add to. But something that I've realized is that I need to start grouping some things into sub-objects just to kind of try to make things more modular. Sometimes I try to avoid doing that, and I think that can be helpful sometimes, but it can be like this whole game has gotten a lot more complicated than I initially pictured it would be, so having a little bit more structure to things is going to be helpful. Okay, so what we're going to do, let's just close everything here. So so this is the main class for an entity, which is like a ship or something. There's some other types of game objects like projectiles, but we mostly care about entities. So we're gonna add a debug viz field here. Oh, nice. Okay, so Slim Kaka says, I just stumbled upon your Oregon Trail video midway through this second day trying to teach myself basics of coding by recreating the Oregon Trail tailored to fake world lore from a podcast. Nice. I'm glad to hear that. I've noticed a lot of people have watched that video, and I know I really need to keep going with it, and I've got some ideas. I need to just sit down and review what I did because it's been a while. But yeah, that's a pretty cool video, and it's one that a lot of people seem to be interested in, and I need to refresh myself on what I was doing with that project. This is a quite a bit more complex project than that, what I'm working on now, but I hope you still find it interesting or maybe useful in some way. So, okay, so yeah, let's just call this debug viz. And we don't have a type yet, so that's just going to be an attribute. Oh, yeah, I'll tell you what, stay tuned. I am really intending to get back into that project soon. I don't know if it's going to be this weekend, but it'll be soon. I do have some ideas for it. And if you have ideas of features you'd like to see me add or specific things, make sure to leave a comment or let me know, because I got some good ideas from a couple of the comments. Like somebody was wondering about how you would make a save system, and that, like, it sounds funny, but that wasn't something I was really even thinking about until somebody said that. So yeah, anything that you're interested in seeing specifically, let me know. Also, an interesting thing about that, I'm gonna show you. So something that I mentioned, I don't know if you caught in the first video, is that I was kind of thinking about when I was writing that maybe someday I might want to actually make that game for an old microcomputer. And since I got that video, I don't, like, in the first video I showed those books that I got from my dad that has the old microcomputer games that inspired this project. I actually got my dad's TRS-80. So my dad's TRS-80 Model 1 I have right there. And something that I would like to do is I would like to look at what it would take to get that game or some subset of that game or something like that actually running on the TRS-80. And I can talk about that in another video, but I figured out a really good way to get software onto that system without having to use cassettes or like type stuff in. So that might be something that we get into in that series eventually too. Oh, okay. Yeah. Yeah, you should definitely check out those videos though at some point. They're they're pretty interesting. Okay, so we're just actually we'll just call this entity debug viz, and we'll fill this in. So the idea here is going to be that we want to show some different arrows and things to represent things that are going on with the entity. So we're just going to have this class and it's just going to hold a few different things. So we're just going to store, let's see, yeah, we're just going to start with np. It's going to be a node path, and it's going to be a node path. Something else that I figured out since the last video is how to is the proper stubs for these Panda 3D. I'm using the Panda 3D engine to make this game, and I was able to install the proper stubs, so I get much better autocomplete for them. Okay, now we're going to make this optional because we don't necessarily want to have it. Okay, so Slim Kaka says, I'm starting without, just trying to make single string HTML right now because it's the most understandable to me. Yeah, that's funny. HTML was kind of one of the first things that I learned too. Actually, when I was a kid, the internet was fairly new, and I remember finding a book about HTML at the library and making little web pages. It's a good way to start, and you know, you have JavaScript in there, and browsers nowadays have like tons of JavaScript debugging tools built in. So if you have a computer, you have a browser, that can be a good way to start programming. Okay, so let's make a function now here to add a debug viz to an entity. And actually, I'm trying to avoid, got a lot of stuff here. So we're not going to start out with these. So Slim Kaka says, Tried hard even with GitHub to convert and move, but for some reason so far I can't wrap my head around it. Yeah, I mean, I think um I think for starters, like I wouldn't think too much about like tools. I would just start with just like simple file editors and stuff. Um File comparison change tools. I mean, like if you're trying to learn how to use Git, I think probably in GitHub you could use the GitHub desktop application. That works pretty nice for comparisons. I use GitK. That is a tool that is sort of built into Git. For simple projects though, I mean, if the pain point for you is Git, just don't worry about that right away. Just focus on learning HTML or programming or whatever you're trying to learn, and then look at the tools, the other tools later, for sure. But yeah, I mean, I think Git is definitely a really important thing to learn, and having a UI tool like GitHub Desktop or GitK would definitely be helpful. Probably I would recommend starting with GitHub Desktop. You're going to find a lot of tutorials about GitHub Desktop as well. Also, if you're using an IDE, I don't know if you're using an IDE, but a lot of IDEs like VS Code have built-in Git stuff as well. So, and those would be well documented in terms of like being able to find tutorials and stuff like that. No, I gotta see if I have. Pretty sure I've got some functions for making. Maybe I don't. So I've got some functions for making arrows. Yeah. Somewhere I've got some different tools. I might have gotten rid of that. For making different shapes. So Slim Kaka says, I wish I really had struggled my brief attempts using Git and other tools. Single test by test, small integrations are my only move to keep current file intact with small changes. Yeah, I mean, that's that's generally how code works. I mean, I think once you get a little bit better, um, you can start making sweeping changes to things. That's something that I struggle with sometimes, is like, I'm always wanting to make little incremental changes, and sometimes you just have to go for it. But that's just a part of coding, and usually a lot of times there it is, shapes. A lot of times you use different techniques to make sure that you're not breaking things as you make changes. So that might be something that you'll see as I'm working on this, is like I can make little changes and then I can test pretty quickly to tell whether I've broken things. And like that's what I was showing at the beginning, is that little example is like it does a lot of different things, so I'd be able to tell if anything was broken. And that example has shown some things to be broken, like the like that behavior tree issue that I mentioned. So okay, yeah, so here's shapes. Actually, let me there's another functionality here called trace, and I think yeah, we want to do something like this. So want to make, do I want to make another? Yeah, I think we have to. This is going to be kind of a lot of messing around here, but I think it's going to be a cool payoff when it's finished. Okay, so yeah, we're gonna we basically just have to build this object that's gonna hold data that we can modify, and let's see here. Because we need to be able to actually modify the geometry of what we're doing. I don't want to just scale it, scale the arrow, because I want to actually have like a little arrowhead that doesn't scale. I want to be able to scale the length without making that arrowhead scale. Okay, so so we need to build it, and then we need to be able to set the length. Arrow set length. And then these are actually going to just be the arrows. I'm going to change this. And then I'm going to wire this up like this. Okay, so we're gonna follow this trace thing here. So we're just gonna add just see how we did this when we build trace. What goes in there? Oh, that's got a start pause. We add another one at the end. I think we have to add 2 positions, right? Because we want the head and the tail. Okay, so I know IDKM locate kind of board says, "What's up? What are you making with what libraries?" Python is a unique choice for game dev. I personally find it fun for 2D games. Yeah, so I'm using the Panda 3D engine, and I'm making a retro space combat game. And right now I'm kind of working on some debug visualizations. So I'm working on making some arrows, and I've got to do some kind of geometry modification here. So this is kind of a mess, but I'm hopefully is going to be done with it pretty soon here. So let's see here. So we'll start. I was going to just start at 0, and then I think we can just do this for now. Yeah, we've got to do the color too. Actually, let's just look at here when we update. Yeah, we just let's see here, update segments. What do you call that? Oh, okay, yeah. Yeah, okay. And we're just gonna set the color to our standard color for now. So we're just making basically 2 points here. For now. Path prim. Oh yeah, and then we've got to make our path primitive. So our path primitive, we just need to add 1. So we basically just need to go 0 to 1. Okay. And let's see, path vertex data. Where's path vertex? How does this? Oh yeah, that comes from there. That comes from there. That gets wired up. We don't want to set color on it. We don't want to do that. And okay, so now we can return our arrow here. So we just have the v data and yeah, path vertex data XMP is path jam node. Yeah, okay. Yeah. Okay, so Slim Cockeye says, thoughts on if I'm better off on starting over, continuing to simply build back up my code with what I have. Yeah, I don't know. I think with programming, there's advantages to starting simple, and there's advantages to like just diving into something complicated. It's really hard to say, but without knowing more about your project. But I think there's advantages to both. So now, if we want to set the length of this arrow, and I'm just going to make a note here because we don't have the arrowhead yet. But if we want to set the length of the arrow, then all we have to do is get a vertex writer. Vertex writer of the arrow's v data, and then we need length here. It's just going to be a float. So basically, so we're going to just reset the first one to just our normal 0 vector. And then the second one is going to be our length. And there's a nicer way to do that, but it's fine. And this we'll call build arrow. Yeah, and then what we're going to do is we're going to set, we're going to scale these things up by scaling the node paths. So we'll just start here and see how it works. And then we want an update function. So update debug is on our t. And basically, if it's none, then we're just going to return. Actually, make a scale thing here. Okay. And we're just going to start with the velocity arrow because I'm expecting to have some problems getting the rotation arrow right. So we are going to arrow set length. Let's see here. Grab this out of here. probably don't want to be setting the scale all the time, but we'll refactor that out in just a second. Okay, so now what we're gonna do here too, when we make this guy, we've got to reparent this cp.reparent to. Now we've got to do something else here, which is we have to get this in the coordinate system of the of the entity, because I want to have these parented. I don't want to be yeah. So we want to get the relative vector. So because these physics things are in the global coordinate system, so we wanted ace np dot get relative vector of ace dot parent of phys.vpos and so this is just local. Oh yeah, we've got to actually rotate. Yeah, we actually gotta. Yeah, we can't just set the length. We have to actually set the we have to set the point, don't we? Length. Set arrow set back. Back is a back 3. And that's just gonna be this. Okay. So arrow set back. And pause local, and we'll set the scale, and that should work. Yes, that's right. So, so Slim Kaka asks, does parent then mean both are tied to each other at a lower level resulting combination? Yeah. So the idea when you're doing 3D rendering, you usually have something called a scene graph, and you can think of the scene graph like a tree. Like you have a parent, and then underneath that you have children that have like a parent relationship, and you can traverse the graph when you're rendering and stuff. So when I say parent, then it means like this object is belongs to the object above, and it will sort of move with it. So like what I'm talking about doing here is I'm gonna have this arrow that's like a debug visualization of the ship's velocity, and I'm gonna attach that to the ship so it moves with it. And what this is doing is it's actually, because this is like the vector of the ship's velocity in a global coordinate system, I actually have to move it into a local coordinate system because I'm parenting it to the ship. So once it's parented to the ship, um, if it's in the coordinate system of the ship, then it'll be in the proper global coordinate system when things are rendered. We'll see. These things are always tricky and they're easy to get backwards, so we'll see if I got it right. Okay, so I think that actually takes care of that. Now, let's eventually we want to turn this on and off. For now, we'll actually just turn it on, and then we will let me just do something that updates this. So update. So here's the main game loop, and let's see here. Update traces, update projectiles. I think there's update targeting on, so it's going to be like in the same spot that we want to update this. So yeah, we'll do it after we do traces. Update traces. Update is and then we want to like debug dot. Whoops. Oh, that's interesting. Debug isn't in here. Debug dot update debug viz. And I think for a scale we want something like 0.2. Otherwise it's going to be too big. Okay. Now, if I run this, I'm expecting this to crash right now because we're not instantiating these debug objects yet. But it's a good sanity check. So, yep, failed to construct object. Okay, so now what we're gonna do is when we construct our entities, we need to give them these things. So, and we're gonna do a whole word. So there's only a couple places in the game where we actually construct these. So is none. We'll just start with nuns, and then it shouldn't crash, and it should basically run as normal. And then we can come back to this and yeah, okay, so now we're running as normal. So now in my big main thing where we're constructing most of the ships, we're going to actually call this. So let's see here. Okay. And, oh, not build arrow. This is just going to be none, and then we're going to add, debug dot add entity. Okay. Failed to construct. Okay. Base MP data. That's weird. Okay. Now let's just pause this quick and take a look. Do we actually see these velocity arrows? We do. Yes, look at that. So you can see that they're kind of hard to see because they just look like the traces go longer. But you can see that there is like a part that sticks out beyond the end of the trace on each of these ships. Awesome. Awesome, awesome, awesome. Okay, now let's actually Yep, and you can kind of see them vibrating a little bit with the way the behavior trees work. And then there's that behavior again where the behavior tree on this big ship stops for no reason that I have to fix. But, yeah, see, it's set back and done. That's funny. Okay, well, that surprisingly worked. Let's try to get an arrow head on there. Okay, so I'm picturing just like a little triangle. So a little triangle shaped arrowhead. And let's see here. I'm just trying to think about the best way to do that would be. Because there's different ways I could do this. I could rotate it to be pointing towards the yeah, that probably would be easiest. So let me just do a quick, let's see here. Oh yeah, I basically just want look at. Yeah. Okay. Yeah, I always forget this. So we basically just want we just want to do a little look at here. So okay. So head p equals p, and we're gonna add a thing to this head and p, and path of shapes dot shapes sooner or later I'm going to run into some circular import issues here. Dot circle. Oh yeah, probably a dumb question, but I heard you mention earlier when the arrow visuals test worked, you could see the reverberations from trees. Might have missed you. You definitely heard me right. So the so I can just show that again quick. So you can see the little they look like just lines that are coming from the ends of these ships here. And do you see how they kind of wiggle a little bit? So they kind of, at first glance, they look like just sort of an extension of the line that is following the ship. So those lines, I call them traces. They're just like a way to visualize where ships have been. You can see sometimes those the velocity arrows, they're pointing where the ship will go. They kind of wiggle back and forth a little bit, and that's because the behavior trees that control like how the ships fly and where they move, in certain situations they will kind of like they don't produce like a smooth control. They will sort of vibrate or toggle back and forth between like saying I should steer this way or steer that way. So they're not always smooth. They kind of wiggle or vibrate. It's kind of like if you were playing the game, you have your joystick, and instead of like very smoothly moving the joystick, as you got closer to like aiming at a thing, you would kind of start like wiggling the joystick back and forth to try to adjust to get a precise aim. So you can see that in those arrows, and that's the kind of thing that I was hoping for with this, is like to be able to see some of those behaviors, because when the controls can be kind of jerky, but the motion can still be smooth because it kind of gets averaged out. But you can see with that arrow visualization, you can see the control not being smooth. Okay, so now when we So to set the position of the head, we're going to set it to 0, have it look at that point, and then move it to that point. Okay, so Slim Kaka asks, hypothetically, what happens when behavior trees are like that? Or if you want to make changes to those behavior mechanics. I'm sure I'm saying this wrong, but talking about integration-wise, mechanics are working together. Yeah, so, well, okay, so I'm not exactly sure what your question is, but, you know, like what happens when, well, you see that kind of like rough controls. That might not be bad. There's advantages and disadvantages to things working like that. I'm not like a behavior tree expert or a control theory expert, but it might not matter. You could add additional things to try to like filter and smooth those outputs, but then that might interfere with the behavior in other ways. I'm just kind of starting to get into how the behavior tree stuff works in my game, and I'll probably understand it a lot better later. And this debug visualization stuff will help with that for sure. I don't know if you had a more specific question, like, I'm pretty sure like if you looked at the behavior trees for a lot of commercial games from this time, I don't think they would have like very smooth behaviors. I think you'd see a lot of that kind of rough control type stuff going on. Okay. Just 1 second here. Oh, nice. We got a few people watching. Fun. Okay. Yeah, alright. So yeah, so to update the head, we're going to set the position to 0. We're going to look at the target point, and then we're going to set the position to that target point. And this is almost certainly going to produce something that looks a little goofy, but we'll see. Oh, and I bet right off the bat we didn't set the color and stuff on the head, so gotta do the same kind of stuff. Path dot set color call, and then we gotta do all this Yep. So it's like, so Slim Kaka says, I guess if you want arrows tracing ships, create successful tests and later want to alter arrow behavior display based on ship speed and other factors. Yeah, I mean the idea of the arrows is not to have the arrows themselves, but it's to be able to debug those things, right? So the arrows are sort of a tool for understanding what is going on with the behavior trees. And let's see here. Okay, I'm not seeing the arrow. That's interesting. Let's just set a really big scale once and see if that makes it show up. Oh yeah, there we go. Okay, and the color isn't showing up, but that's okay. Get the target. Yeah, okay. Yeah, you can see the arrow now on the end. I think the color is just going to be simple as setting a priority. For whatever reason, sometimes you have to set a priority. Yep, and then yeah, so now we have to add an extra rotation here. So I think what we want to do is I just want to make this shapes function a little bit more expansive. So we're going to actually we're going to make this function basically call an internal function, and we're going to refactor this later. But because I want control over the starting point of it. Because we want the starting point. Oh, and that's going to be another problem. Is that going to be a problem? Oh, that's interesting. That is really interesting. Because this is making a circle in the XZ plane. See, this is, yeah, this is designed for UI. Actually, here, let's just do this. Let's just make a new function. Okay, let's find another song to listen to here. Oh, nice. We've got a lot of viewers right now. Okay. I'm gonna listen to some more intense music from White Bats. This is his 4-hour cyberpunk dark synth mix, Plasma. Okay, yeah, so this is kind of like, this is kind of for UI stuff. We're just gonna make a new one that is for this will have the start we will see, is it XY? Yeah, we want XY plane here for this one. Okay, cool. Yes, this Slim Kaka says feels like a background sound to be integrated into your finished game. Yeah, it really does. A lot of this, I don't like all of it, but some of these White Bat audio sounds are great, and I've used his music is royalty free, kind of lets you just use it for free for different projects, and I've used it for different trailers and stuff. And I need to do that more, because the trailers that I use his music for are some of the most viewed videos on my YouTube channel. I credit that, I think, to some of his music. Okay, so what we want to do here now is we want to use circle XY, and we want to start at we want to start at tau divided by 2, so we get a point pointing forward. Okay, now let's see if this looks more like what we want. Target, yes. Okay, this is definitely getting closer. But this is still, now that's still aiming sideways. XY plane. Does look at not do what I thought it did? Oh, not tau divided by 2, it's tau divided by 4. Jeez. Okay. Now what's going on with this? What is going on here? We've got like we've got an arrow. We've got 2 arrows, and they both have like weird little tails. What is going on there? That is so weird. That has to be this new arrow thing that I added, right? This head? Like if I don't do this, will both of those disappear? Yeah, that's weird. Well, one of those... Yeah, what's going on with that? That is weird. Zero, and then look at it. Oh, that's what's going on. got that. I've got this in there. I don't want that in there yet. Okay, now, why are we getting that weird little tail off of that? That's why we forgot to swap this around. Okay, that should fix that. Okay, now we goofed something up. I'm sure it's just, yeah. Yeah, there we go. Okay, now if we wanted to, and I think I do want to, see how this is aligned with sort of the middle of that arrow? I want it to just be at the tip. But this is like exactly what I wanted here, so see, we can look. We can see this guy's facing this way, but his velocity vector is going that way. See, he's reversing. Oh, that is really cool to look at. And I think I've got the coordinate system right, because it's definitely tracking with the trace. Oh, that looks really cool. Yeah, okay. So let's try to align this. So okay, what do we need to align this? We need to align it. If we're going to align it, we need to move it backwards across that arrow by whatever scale factor, or backward along the vector by whatever scale factor it has. So yeah, now as it is, there's something a little weird too that's going to happen, is that this will scale with the scale factor. Oh, actually that's right. That's what we want. Okay, so just like naive center of arrowhead at back. What we want is something a little bit more subtle. So we want to subtract from this vec times, actually I think it's vec times arrow.headnp.getScale, right? Because the radius is 1. Whoops. Oh, so this is just gonna be get scaled. This is just, yeah, that'll be fine. Okay, let's take a look. Nope, that did not work. That did not work at all. Oh, now we goofed something up. Oh. Oh, we gotta, hmm. I've got to think about this here. Minus fact, I'm pretty sure that's what we want, so why didn't this work? Okay. Doug Wise is here. He says, missed first hour, but the ship tracks look great. Oh yeah, thanks. I've had the traces for a while. Those are actually a little easier than what I'm doing now, because there's less like coordinate system nonsense involved in that. So let me just log some stuff here. So let's see here. Nice. We still got about 11 people watching. I hope everybody's doing well, and I hope if you're watching that you're encouraged to work on whatever creative projects you'd like to work on. That's what this time is for me. It's my time of the day to work on something kind of small but important to me, and I hope that you're encouraged to do the same. Yeah, so why? Because I want it, so like we're going along this vector, right? So I want to move backwards along the vector by the scale factor, and I'm not multiplying. I'm setting that scale here. I'm setting this a scale here, but I'm not setting a scale on path. So I would expect the scale here to say 10, right? 10, 10, 10, yeah. So why don't we get... Where is it? Don't we have a nice... Yeah, something's going on there with the targeting. So that might be what's goofing up my behavior tree. It's like it's targeting itself. Yeah, okay, so let's just add some... Let's just see what's going on here with... We'll print out where it would have put it, and then where it is actually setting it. So as I was, and now we're setting it at oh yeah, see, that's way heck. Oh nice, Jupiter BJY is here. Yeah, I'm debugging this this arrow placement thing. I'm just making a dumb arithmetic problem thing here. So, oh yeah, so okay, so I'm assuming that I need to look at. Oh yeah, so this needs to be just the normalized version of that. Duh. Okay. Yeah, there we go. There we go. That's what I wanted. Okay. Yeah. Yeah. Look at that. Beautiful. Yeah, the shields I'm happy with. There's a couple things that I need to fix. There's an animation for when the shields are destroyed that I don't love. Um, but the general effect, and it needs to be tweaked, like kind of like tune the magnitudes of different things, and um, when the game is paused, there's a it translates between the different targets. Oh, that looks so cool. Let's see, does the... Oh yeah, the zoom works when it's paused too. I added the scroll wheel zoom free look to the external camera view too, so you can like just like pan and zoom around with the mouse too. So that's kind of fun. Now, like I think I can turn, let's see here. Now let's figure out how to trace toggles F5s. Yeah, so like you can see if I turn the trace off, it makes it a little bit clearer what that arrow is doing. Yeah, okay, cool. Jupiter BJY asked, does zoom work by changing FOV or moving camera closer? It is a true FOV zoom, and I think I've talked with you about this before, but it's something I'm really proud of. The stars stay the same size under zoom, so let's see here. So I'm basically changing these stars are little polygons, and they get scaled the opposite way of the FOV zoom, so it looks right. For a long time I had a bitmap texture stars that I got from NASA, and I replaced that with these geometric stars. And I really like the effect of the FOV zoom, because it looks a lot more like, I feel like, what you see in sci-fi TV and movies. Like I was looking a lot at the space combat in Battlestar Galactica, and they do a lot of, and The Expanse, and they do a lot of what looks to me like FOV zooming effects. And what I want to do is I want to figure out too how to integrate that a little bit better into some of the animation. Like if I go self to target, that this would kind of get at it, right? Like you could sort of reset and then zoom in, and you get that under high zoom, you get that cool flattening effect. You get the flattening effect, and you see like the stars move faster too, which is something that you wouldn't get with the moving the position of the camera. Right, so both of those are nice effects that you get with the FOV zoom. Okay, this is looking good. Let me just see. We still have quite a few people watching, so I'm gonna eke some watch hours out of this and keep going. We're gonna try to do the rotation arrow too, which is probably gonna give me some grief, but that's okay. So I think we've got a lot of the mechanics of this figured out. So oh, nice. So Slim Kaka says that, man, I just saw you link to Amazon to your books. That's awesome. Definitely going to download both and check them out tomorrow. Awesome. I'm glad to hear it. Those books, they are set in the same world that you're seeing here with this space combat, and they're a neat mixture of sci-fi and horror and maybe some fantasy elements in there too. And the game that I'm working on is hopefully gonna have some of those elements too. It's a very long project, and you know, it's kind of a hobby, so I don't know if there's like a certain time when it's going to be done, but the books are done, and especially the first book. It tells a complete story, so you can read it beginning to end. Jupiter BJY says it has horror. Hope I can handle it. It's not maybe the most intense horror. It's like it's not like gross out horror. It's kind of more like H.P. Lovecraft. You know, like space demons, some occult horror stuff. So yeah, I don't think it's anything that most people would find too scary. Okay, yeah, let's try to do the rotation arrow here. So okay, so we'll make a rotation arrow, and we'll set the color of that to do we have a blue? Let's see here. Jupiter BJY says, since I'm not English native, I'll probably need a dictionary next to me while reading it. Ha ha ha. Yeah, maybe. I don't know. I don't think that my book has like a crazy big vocabulary. I tend to not use a very crazy or sophisticated vocabulary when I talk, and part of what I wanted to do with my book is kind of tell a story in my voice. So the narrator and most of the characters aren't like super eloquent or use a lot of like crazy words. I think it should be pretty readable. I don't know of anybody. I gotta think. I don't think I know of anybody who is not a native English speaker who read it, that I've talked to. So I would be curious if somebody did, what they thought of it. But yeah, I don't think it's anything crazy in terms of the vocabulary. Okay, so okay, so now we want to update the rotation arrow. Okay, so basically we want to get a local vector that represents the rotation of the ship. And the way we're going to do this is, so our ship's rotation is described by a global coordinate system quaternion. So we want to basically just extract the axis of rotation out of that guy, and then do the same kind of thing here where we get a relative vector, and then yeah, something similar. Actually no, yeah, except yeah, we've got to scale it then by the actual. Let's see, what do I have? Viz dot. Oh, okay, yeah, I don't have it's not a quaternion, it's HPR. So that actually 3. Let's see here. See here. So I wonder, let me just look in my horrible physics integrator and see if I've got anything that I can use to get that. Oh, let's see here. This horrible stuff here. Oh, angular. Awful stuff. Yeah, my big project that I've planned for the next couple months is I want to fix this, and fixing it might mean I don't use it anymore. I originally, just kind of wanted to do everything myself. I've struggled to I've really struggled with understanding some basic things about how 3D physics, how you'd write a physics integrator, specifically on the rotation side, and I am fairly confident at this point that I'm doing my behavior trees the right way. So I moved. I changed how the angular acceleration control works to a way that I think makes a lot more sense and should work better across different like integration backends. So I'm not too worried about swapping things out, but yeah, I think, let's see here. I think basically what I want here is I want to get I know I can get the axis of rotation, but I want to get the actual angular velocity vector. So what am I doing here? Mass body. Like, where's the magnitude from this coming from? Is momentum linear? Momentum angular. Where is momentum angular being set? Let's see. Yeah, so Jupiter BJYS, so there's 2 books. Yeah, I self-published the first one in 2019 and then the second one in 2020. And I've been experimenting with writing other stuff since then, but I haven't quite come up with anything that I want to publish since then. We're just gonna throw some stuff together here for now. I don't know if it's gonna be right, but Jupiter BJY says I never bought the digital book from Amazon, so I'm not sure if I can watch it in phone though. Yeah, I think if you buy it from Amazon, you can either read it in the Kindle app or I think you can read it on the website too. I think they have an online website reader. Slim Kaka says, holy crap, I just looked at procedural 3D tree structuring. Seems close to what you're doing, so much cooler and impressive than I could try to fathom. LOL. Glad I stumbled upon you. Yeah, I mean, so this is like trees in the context of a 3D scene. There's also like other kinds of procedural stuff that you'll run into. I think, you know, as you become exposed to these concepts and have a chance to think about them and how they're useful, you'll wrap your head around it. I remember thinking about some of this stuff when I was first exposed to it, and you know, uh, it all seems complicated, but you start looking at it a little piece at a time, and things click. Okay. Yeah, we're just gonna throw some stuff together here. I don't know if this is gonna be so we just want a function that gets the magnitude of our rotation. So I think we just want to copy this. And we can just have all the torques be 0. I just want to get a number that isn't completely, and this, yeah, this is just going to be 0. Because I think torques here are, yeah. And then if we update this with, and I'm just gonna hard code this for now. Yeah, it's just constant step took time. And then we should have our in here we should have our angular momentum, but that's still a state. We don't have a, we just don't have a number here. We don't have a, see, what I want is like, I want the magnitude of that thing. And I don't think, well, yeah, Slim Kakas. I don't know exactly what I'm doing here either. You know, here's what we're gonna do. Actually, we're just gonna forget all this stuff, and we're gonna say to do do this properly, and we're just gonna return the length of the state. We're just gonna return the we're just gonna return the length of that HPR vector. I know that's not right. That's not right. But it should give some kind of representation of what's going on that will be useful for visualization. So I think this angular velocity vector here is what we want, because this is transforming a vector, and I think this is like a I think this is like an actual axis, rotational axis with magnitude. But I don't want to jump through all these hoops just to get some random number that isn't quite right. So we'll save that for another time. And okay, so yeah. Oh, Jupiter BJY asks, is EOE abbreviation of esoteric order of the engineer? It was immediate. It was on immediate first chapter. Yeah. The EOE is one of the bad guys, bad guy groups in the story, and you probably see some EOE stuff in what I'm working on here. So the this ship, this Ashinoko, is a EOE designed ship. So it's like they're very make some very advanced designs, and like they're kind of like they're kind of space pirates, but they're like very high tech and mysterious space pirates in the story. Okay, yeah. Yeah, okay, so what we're gonna do here, so we have this we have our angular velocity in this really awful format. We want to convert it to a quaternion, get the axis from that quaternion to point our arrow, and then we're just going to estimate a length for the arrow now, this kind of bad way. And there's some other spots in this where we where we do this kind of conversion, and I'm just gonna see if I can find one, because yeah, this is just like this is a little unintuitive. So we're gonna set this fizz, and then yep, so now the axis is going to be temp.getAxis, and then this is in the local. So we've got a, oh, okay, actually, yeah, that's, actually, no, this is, yeah, this is not local, this is global. So we've got to convert this to local, yeah, so axis local is going to be this thing again, get relative vector, and we'll see if this looks right, or if it's flying all over the place. And then we were going to scale this by our magnitude here. So it's local times get PR mag. Fizz, and then we are going to set that with arrow set vec. So arrow set vec debug fizz dot route arrow with axis local, and then update the scale with our scale, which we might want to have separate scales, but that's okay. We'll just try it for now. Set. Okay, let's see if this looks like anything. All right, well, we've got that. Okay, let's see here. Build arrow. We're gonna have this take a color. UIC dot wireframe color, and we're gonna make this cyan. Build arrow color. Oh, nice. So Slim Kaka and Jupiter BJ are having a nice conversation about CNC stuff. That's cool. It's really interesting working with this stuff because it is very, like, there's very concrete applications to real world things. It's funny because, you know, you can be like making a game or something, and but then, you know, this stuff is also used for for things like actually making real things. Oh, okay. Yeah, so as far as I know, I'm storing angular velocity in global coordinates, but I could be wrong. And we may or may not be able to see if that's wrong. Based on this. Let me just go into global coordinates here so we can see what's going on a little bit easier. And then like that seems, at first blush, that looks right. Like I feel, well, is it? Yeah, generally that looks right. Maybe. I think it needs to be, the scale needs to be a little bit bigger. But like, okay, let's see. Like, does that look like the axis that thing is rotating around? Almost. Oh yeah, I you know, I've thought a lot about these things. I've even done it for work, and I still just have trouble. I still have trouble with it. That's one of the main reasons that I'm building the stuff that I'm building right now is I need to be able to visualize this stuff, right? I can't be flying by the seat of my pants. I've got to look at it. I've got to look at it and be able to double check and see that I'm doing what I think I'm doing. These are changing pretty fast. Now, see, that's not right. That's not right. He wasn't. That didn't look like he was rotating. Now, I wonder. Okay, I bet I know what's going on, and I bet that those are actually local. Yeah, okay. They're almost certainly local, not global. Now that I think more about it. Let's see if that's the problem. So basically I shouldn't have to do this conversion. I should be able to just say so I shouldn't have to do this. I should be able to just do this. Axis. Okay, let's take a look. Yeah, so Jupiter BJY is talking about different ways of converting. What I want to do is I want to do everything with quaternions. And I want to get away from anything that isn't quaternions, because I feel like every other representation of this stuff, you're just gonna shoot yourself in the foot somehow if it's not quaternions. Okay, that looks better, right? That, I think, That I think looks... Oh, I need to go back to... target to target, and I want global. No. I don't know. I think we gotta add, we just gotta add a little bit bigger scale to this too. Let's see here. Target to target, and let's do global align pause. Whoops. Yeah, that's what's going on. Okay, so we should see this guy if we do. Yeah, okay, that looked right. Okay, so here we should see him. Yeah, yeah, I think this is right. I think this is right. It is flopping around a lot for small rotations, which is kind of to be expected, but yeah, I would say that looks right, right? I mean, the axis processes sometimes, depending on the motion, but like, I feel like you can see it. You can see him. Now, here's another thing we can do, right? Let's go to a different scenario. And we'll just give ourselves a little ship that we can check this with. It should be really obvious for a player-controlled ship if this is right or not. Yes, so Jupiter BJY asks, is the cyan arrow the angular velocity is quaternion on the axis? Yes, that's the idea. So it's basically like whenever you have a 3D rotation, you can express that as a rotation around a specific axis. So that is the axis of rotation. Yeah, look at there. So here, let me just turn off that other player so he's not. Yep. See, that is at least. Okay, now let's zip around and get all out of whack orientation wise and see if that still looks right. Yep. So I'm getting a nice straight up and down arrow when I'm. Yeah. Okay, so this this pretty much proves that we've got this right. This is what I was expecting to see here. It's a little bit annoying having those. Maybe I've got to figure out a little bit better way to visualize things when it's 0. Just have it completely disappear. That's probably what I should do, just so we don't have these random arrows kind of floating around. But yeah, this here is pretty much looking like I expected it to. You can see my velocity arrow here follows my little velocity indicators that I have. And yeah, the angular velocity. Again, that magnitude, I'm definitely not calculating that in any kind of way that makes sense, but it is close enough to kind of visualize what's happening. Let's just make it so that we hide everything when the magnitude is smaller than a certain amount. So basically, if vpos local.length is less than actually, yeah, we don't even need to. So if ent.viz.vpos is length is less than something like 1 meter per second, then we just don't bother doing this. We do debug biz.belarrow.basenp.hide show, and then same here. So we'll just get the mag right away. And if it's less than, I don't know what a good amount for this is. Show. In so Jupiter BJY says, I really didn't have anything to represent linear and angular velocity, so I just draw a voxel grid of lines around ship as a reference of world space, but that's too dirty. Yeah, so I do something like that too. I have this grid that you can turn on and off that kind of shows the world position when you're in this external view. So I have like these three grids, and then they kind of scroll. They scroll with the player, so like if you start moving, the grids stay in position, but then they hop over like that, so you can kind of gauge things. Something that is pretty important to how my game works is do something called like a floating coordinate system, where the rendering coordinate system, the ship is always at 0, 0, 0, 0, and that way you can be like moving all over the place, and you don't have jittering vertices and stuff. You can like move over really long distances and everything. Yeah, and the idea is eventually too, I'll modify things so that the local coordinate system is like, origin is whatever the camera is looking at, not at the player. So you could like jump around to ships that are really far away and still get good results. Okay, so this is basically what I was wanting. I'm gonna get rid of that scale times 2 multiplier on there, and well, actually here, head, this we can make a little bit smaller. The arrowheads are big. Yeah, so the way it works is there is a physics state that the ship has, and this is like its true global position and stuff, and then I update from this to the actual like rendering position. And what I'm going to do at some point here is I'm going to make this position a double precision thing. And then I can do really crazy distances, and I'm going to start experimenting stuff with actually planet gravity and orbital mechanics and stuff like that. Because with double precision coordinates, you can basically do whatever you want. Yeah, okay, so this all really appears like it's working. Let's go back to that first scenario and enjoy. So here we are in global coordinate system. We have nice small arrowheads now, and we should see, yep, this seems right. This seems right in terms of how those rotation arrows are moving. They definitely precess sometimes, but that's going to happen for certain kinds of motions. Man, that looks cool. A lot of these things, it's like, why didn't I do this sooner? Yeah, so Jupiter BJY says, for me to use double precision, I gotta recompile. So I would have to recompile Pandava to do double precision for the rendering stuff. I'm not talking about doing that. I'm just talking about storing the actual physics, like the main like coordinates as double precision. I think single precision is fine for for like one area that I'm looking at, especially with the floating origin. But with double precision, I could really have a much bigger range of coordinates that I could do computations over, like gravity or different things like that. So let's see, like if we turn off traces, this looks kind of cool because it's I think that's what's going on. I think it's when I hit enter, it targets, I'm targeting myself, which doesn't make sense. Yeah, we can turn off the trace. That makes it a little easier to see the velocity vector. Let's look at this just once more. Oh, I see Prairie Fox is here. He says, "What's up, David?" Hey, how's it going, Prairie Fox? Let's see here. Yeah, all right. Well, I think we set out what we wanted to do here. I mean, I think there's some constants that probably are going to need tweaking. So, you know, the scale that you want to show these things at obviously matters. I am just invoking these things with a certain scale here that I'm passing in, and then I have a different well, actually, I got rid of that multiplier. But I think, yeah, I think what we want to do is we want to have a scale for the velocities and a scale for the rotations, and then eventually we'll want to set the scale of the arrow. Yeah, set the scale of the arrowhead kind of opposite of that scale so that we can keep the arrowheads the same size. Actually, let's see if we still got some people watching. Let's just do that. Okay, so yeah, because we have all of the relevant stuff. So let's wrote, and we'll make a function here for we'll set the scale of the arrowhead to be, yeah, because we want to scale that sort of opposite. Go away. We have the arrowhead set to now. That's 5. So Slim Kaka asking, use a macro style system. Works off the simple coordinate and then reference additional macros. Yeah, I mean, you could build a system like that. With Python, Python isn't like, you don't use too many macros. It's more like, you more use like functions for transforming things. I think some of the things that you're thinking about in terms of like converting coordinate systems, Panda 3D does for you. It is a lot of like my struggles here are kind of like trying to remember how you're supposed to do this stuff with Panda. But yeah, it's the style of Python that I write, like I try not to get too clever with stuff like macros. You just try to, like, you want to try to be clear about how things work. So okay, so yeah, so we're just gonna say scale and let's see what yeah. Oh. Now, what we should be able to do is we should be able to have the rotation scale, for instance, be like way bigger and still see the arrowheads have the same size. So, yeah. So both those arrowheads look like they're the same size, but oops. Yeah, okay. And I think, surprisingly, 0.2 is kind of a good scale for both. Could probably go higher. Maybe... yeah, that definitely makes it easier to see. And if we turn off some of this other stuff, let's see here. That will make it easier to see too, because there'll be less clutter. I probably need a thing to toggle all of the traces. Let me just we should be able to turn some of this stuff off. Let's see here. Yeah, we don't want to do this. Let's turn those traces off, and then we want and then we can just toggle that off like that. Yeah. There you can see him pretty easily. That's pretty cool. For this, for the player ship, he's big enough that they don't quite show most of the time, especially the rotation vector, because he rotates slower. But, yeah. With those other UI pieces turned off and traces turned off, you can really see it. Cool. All right, well, I think we're probably at a good stopping point for tonight. The next step obviously would be to add a control of some kind to turn this off, like on and off, instead of just having it on all the time, obviously. But it's cool enough that I kind of like just having it on. It adds a lot, I think, to being able to see what's going on, and looks cool. So definitely a cool addition to have. Let's see here. Set to this off again and global. Does everything look right? Yeah, it's like everything that I'm seeing makes sense. Cool. All right, well, thanks everybody who came to watch. It was fun hanging out with you. And wish you luck in your projects. I'd like to hear more about what you're working on. And yeah, have a good night. Catch you later.